Welcome student. In last lecture we have studied about this most economical circular channel section. Yesterday in last lecture we have studied about the condition number 1, that is condition number 1 for the most economical circular channel section. So what is the condition number 1? Condition number 1 is nothing but condition for the maximum velocity for a circular channel section. Now condition number 2. So condition number 2 is what? So that is nothing but condition number that is a condition for the maximum discharge for circular section, right? We know there are two conditions in circular channel section. So one, that is for the one condition number 1 for maximum velocity, and condition number 2 that is for maximum discharge. So yesterday we have derived that conditions for the maximum velocity. Now, or in last lecture we have derived that maximum velocity. Now today we are going to derive the condition for the maximum discharge for a circular channel section. So what are the conditions for the maximum discharge, right? Now as we know, so what is the discharge, right? So discharge is nothing but the discharge Q is given by, so we know that according to Chase's equation, Q is equal to how much? Q is equal to A into C into square root of Mi, right? If you observe this equation, or you can write this discharge equation in this manner also. So Q is equal to A into C into what is M? M is nothing but hydraulic mean depth. So what is hydraulic mean depth? That is nothing but A by P into I. So this is the equation of discharge by Chase's equation, right? Now so take this A into that square root. So this A will be, if you take that A into square root, that will become A square. So A square into A is A cube by P. So this is the discharge equation, that is Q into C into square root of A cube by P into I, right? If you observe this equation, so this discharge depends upon this ratio A cube by P, and C is an I, it is going to remain constant, right? So means what? So Q is directly proportional to this A cube by P, or it depends upon this A cube by P. So we have to find out what is the condition for the maximum discharge. So when the discharge will be maximum, or the discharge will be maximum for a constant values of C and I, when this ratio A cube by P is maximum. Means what? When this ratio will be maximum, then automatically Q will be maximum, right? So means A depends upon this product, right? Means in order to find the maximum discharge, first of all we have to find out what is this A cube by, what is the value of this ratio A cube by, maximum value of this A cube by P, right? So as we know, so when A cube by P, that is nothing, A cube by P will be maximum when its slope, that d by d theta of, when d by d theta of A cube by P is equal to 0. So at this time this ratio will be maximum, right? Means what? We have to find out that slope of that ratio, or that equation, slope of this equation, that is nothing but d by d theta of A cube by P is equal to 0, right? Now the derivative of this A cube by P, what is the derivative? We know this that derivative of U by V, this is the U by V, right? Now what is the derivative of U by V? We know the formula U by V. What is the formula? That is V into U dash minus U into V dash divided by V square. So U is what? A cube, this is a U, and P is your V, right? Now by using this formula, now find out the derivative of this ratio A cube by P, right? So what is U? Now by using this formula, so V, what is V? P into U dash, that is A cube, derivative of this A cube, that is nothing but 3 into A square into dA by d theta minus U in, that is nothing but A cube into derivative of this P, that is dP by d theta divided by V square, that is P square, right? Now after this, so take this P square to that side, right? So this will become 0, this P square will become 0 now, right? Now what are the remaining terms? So 3 into P A square dA by d theta minus A cube into dP by d theta is equal to 0, right? So this is the modified equation, right? If you observe in this equation, the A square is common. Now take the A square common. So take A square common from this equation, right? So A square, if you take the A square common, so in bracket 3P into dA by d theta minus, if you take A square from A cube common, then what is the remaining term? A. So A into dP by d theta bracket close is equal to 0, right? So take this A square to that side, that will become 0. So what is the remaining equation, or what is the remaining equation? That is nothing but 3 into P dA by d theta minus A into dp by d theta is equal to 0. So this is your equation number 1. Now after this, right, so now after this what, so this is equation number 1, 3p into dA by d theta minus a into dp by d theta is equal to 0. This is equation number 1. Now we have to find out this dA by d theta and dp by d theta, right? So as we know, what is the A is nothing but weighted area. So we have calculated that weighted area for the circular channel section, right? What is that weighted area? That is, we have seen this weighted area, a derivation of this weighted area in flow through the circular channel section in our last videos, right? So A is equal to r square into theta into sine 2 theta by 2 sine theta by 2 into, this is equation number 2, right? Now take this derivative of this A, that is nothing but dA by d theta, because we have to find out this dA by d theta. So therefore dA by d theta is equal to r square into bracket 1 minus, so what is the derivative of this term? That is derivative of the sine 2 theta, because we have to take what is the variable term, this theta, right? Other remaining terms is going to remain constant, right? So therefore d by d theta is nothing but r square into what is the derivative of theta, that is 1 minus 1 by 2 if you take common. So sine 2 theta, what is the derivative of sine 2 theta? That is cos 2 theta into 2. So this 2 will cancel. So what is the remaining term? So dA by d theta is equal to r square into bracket 1 minus cos 2 theta. So this is equation number 3. Now after calculating this dA by d theta, right? So now what is the perimeter? That perimeter we have also seen this equation, or we have derived this equation, that is nothing but P is equal to what is weighted perimeter in circular channel, that is 2 into r into theta. So this is equation number 4. Now so take the derivative of this perimeter with respect to that is dp by theta is equal to, so theta is only variable term, other is constant term. So what is the derivative? 2 into r. So this is equation number 5, right? Now put this equation number second, this third, fourth, fifth in equation number 1, right? So therefore put equation number 1, 2, 3, 4, 5 in equation number 1. So therefore now what is the equation? Let's see here. What is the equation? That is, what is the equation? So 3 into 2 into r theta, right, into r square 1 minus cos 2 theta minus r square into theta minus sine 2 theta by 2 bracket close into 2r, right, into how much? That is 2r, right? Now so this 3 into 2r theta into r square, that is nothing but 6 into r cube into theta, 1 minus cos 2 theta minus, see this r square into 2r, how much it is? So 2 into r cube theta minus sine 2 theta by 2 bracket close is equal to 0, right? Now so divide this equation by 2r cube. So we get, if we divide this equation by 2r cube, what we get? So 3 into theta, right? So into bracket 1 minus cos 2 theta. So this 2r cube will cancel. So theta minus sine 2 theta by 2 bracket close is equal to 0, right? Now after this, so just multiply this 3 theta into this bracket. So therefore 3 theta minus 3 theta into cos 2 theta minus theta minus minus plus, so plus sine 2 theta by 2 is equal to 0, right? So this 3 theta minus theta, so that is nothing but 2 theta minus 3 theta into cos 2 theta plus sine 2 theta by 2 is equal to 0. So the, right, now the solution of this equation, now if you see this equation, 2 theta and 3 theta into cos 2 theta plus sine 2 theta by is equal to 0. The solution of this equation by hit and trial method, so it gives, so 2 theta is equal to 308 degree. Means if you solve this equation, right, so this is a very lengthy equation, so if you solve, you will get 2 theta is equal to 308 degree, right? So therefore theta is equal to how much? 308 by 2 is equal to 154 degree. So therefore theta is equal to 154 degree. Means what? If that angle subtended by that free liquid surface, right, so if this theta becomes 154 degree, right, so then at that time the discharge will be maximum. So this is the condition, that theta is equal to how much? 154 degree, right? Thank you.